All right, welcome to Best Academic TV. In this video, I will show us more on how to solve projectile motion in a simplest way, okay? But before then, I'm going to lead us on how to know projectile motion and how to solve projectile motion depending on the shape. So if you can understand the shape, at that point, you can solve that question relating to projectile motion, okay? But first of all, let's take note on definition of projectile motion. Please take note of this. Please write. Projectile motion can be defined as, please write. Projectile motion can be defined as a motion in a parabolic curve. That is this, a motion in a parabolic curve, all right? But later we are going to know that most of the projectile motion are not in parabolic curve, okay? I'm going to tell us later, okay? Now, a motion in a parabolic curve, okay? Note that projectile motion is two-dimensional motion. That is 2D. Note that projectile motion is two-dimensional motion. Okay, when we are saying about two-dimensional motion, it means that projectile motion can either be on horizontal axis or vertical axis. That means two-dimensional motion is this. Can either be along y-axis or what? X-axis. Please take note of that, okay? This is two-dimensional motion, okay? Can either move in this y-axis or can either move in what? S-axis. It's two-dimensional motion. And also write this note. A projectile motion is a free-form motion or motion under the influence of gravity. Okay? Now, let's consider the shape relating to projectile motion. We are going to consider the first shape relating to projectile motion and the second shape. And each of the shape, I will give us some formulas we can solve any shape relating to their, I will give us the formula relating to their shape. Okay, now let's consider the first shape, please. All right, let's consider the shape and their formulas. Okay, now what you just have to do in projectile motion, whenever you are given any equation, just know the shape. When you know the shape, you apply this formula I'm going to give to you guys. Okay, just know the shape, apply the formula. But some shape will not be known to you. I will also tell you guys how to know the shape. Okay, the first one, please. Class, let's consider when an object is launched on a cliff or tower. Now, what is the shape of tower here? If I have something like this, class, I'll have an object here, and this object can either fall down to this here. Now, if this object is launched on a tower or on a cliff, we have a formula for it. But just know this, that whenever you are solving any equation, here is height, we call this height. Here is distance. Please take note. Here is the vertical side, is said to be height. The horizontal side is what? Distance or length. Okay. Now, whenever an object is launched on a cliff or is on a tower, at that point, the two formulas to consider is this. That the first one is said to be h is equal to half gt squared. While the second formula is said to be d or r. You can use d or r. Please take note. It's equal to vs of times t. So these are the two formulas we should consider whenever we have any question relating to projectile motion when an object is launched on a cliff or tower. Now we are going to know when an object is launched on a cliff or tower. Okay? So let's solve a question first. Let's solve first question, and using that first question, I will explain more on when an object is launched on a cliff or tower. And if you can know this, you can see we can also know the next shape and how to solve question on the next shape. Okay, but first of all, we have to know when an object is launched on a cliff, so I can also know when an object is in a parabolic curve. Okay, let's solve question one, please. Example one, please. Right, let's solve example one here. Before we solve the example, let's understand the question properly before we solve this example here. Okay, it says an arrow is horizontal projected from the top of a tower with an initial velocity of 15 meters per second. So that means the velocity here is given to us to be, that is horizontal velocity, which is along x-axis. Remember, we have something like this. This is our horizontal. Please take note. These are vertical here. So any velocity here should be v of s. Remember, this is s. Any velocity here should be of class v of what? Y. Please take note. Okay. Any velocity acting along this axis should be v of s. If it is force, any force acting along this axis should be what? F of s. If it is force, any force acting along this axis should be what? F of y. So at this point, we are referring to velocity. That is, any velocity acting along this axis should be what? V of s. Please take note. While any velocity acting along this axis is what? V of y. And this is horizontal. This is what? Vertical. Okay. Now they mention horizontal, and this velocity here is horizontal velocity. That means our V of S is said to be 15 meter per second. Please take note. Okay. That's the first parameter given to us here. Okay. Now let's go. If it reaches the ground 7 seconds, that is the t here, the time here is said to be 7 seconds. Please take note. Okay. Later, calculate the height. We are asked to calculate the height. Please take note of the tower. Now, I told us that whenever you want to solve any equation relating to projectile motion, the first thing you should know here is the shape. Now, they say that the shape here is said to be a tower, or if it's a tower or a cliff, we have a special formula for it. Please take note. We are going to write down the formula for any projectile motion having the shape of a tower or the shape of a cliff. Okay? Before we solve this question here, but the given parameters here are said to be v of s. We are indicating this because we have two dimensions, that is s and y. So we have to specify the direction, which is what? Horizontal. So v of s, which is velocity along s direction, is said to be 15, or velocity on horizontal axis is said to be 15 meters per second. Please take note. While the time is given to us, that is t, is given to us as what? 7 seconds. But we are asked to find what? The height. Okay. Now let's try to write down the formulas relating to projectile motion when an object is launched on a tower or on a cliff. Okay. Okay, that means solution here, class. Our v of s is given to us as 15 meters per second. Please take note. Our t is given to us as 7 seconds. Please take note. We are asked to calculate height. Okay. Now the formulas here relating to tower, that is when an object is launched on a tower, is said to be the first one, which I gave to you guys, is height is equal to 1 over 2 gt squared. Please take note. While the second one is distance is equal to vs times what? T. Okay. Now, depending on what we are asked to calculate, please take note of this. Depending on what we are asked to calculate, since we are asked to calculate time here, class, we are going to use, since we are asked to calculate height, we are going to use the formula for the height here, which is h is equal to half gt squared. Please take note. Okay. Now, why are we not replacing vs? Vs is only allocated if you want to calculate the distance here. Please take note. There's nothing like Vs here. In physics, we use the parameter available depending on the formula. Okay? That means using this here, take note, h equal to half gt squared here. Let's replace here. This will be 1 over 2 times class. At this point here, listen. At this point here, I have to replace the value of g. The g is constant value. But we have two values of g. It can be 9.81 meter per second square or 10 meter per second square. But listen, understand this. Whenever the value of g is not given to you, knowing that you have to replace the value of g since it's a constant value, we use the approximated value. And the approximated value of g here is class 10 meter per second square. Please take note. So this is going to be 10 times 7 all squared. Please understand this. We are using this 10 here because it's not given to us. But if it's given to us, we use the one given to us. But whenever g is not given to you and you want to replace the value of g, you use the approximated value of g, which is what? 10 meter per second square. Please take note. So let's solve this, class. Now, 7 all square will give us 49. 7 all square simply means repeat 7 into how many times? 2 times. That is 7 times 7. Give us 49. So this is going to be h is equal to 1 over 2 times 10 times 49. Okay. So this will cancel this. I'll be left with 5. So this will be equal to 5 times 49. Please point your calculator. 5 times 49. What is the answer, please, class? That is 245 in what? Meters. Please take note of this, okay? Let's solve question 2 here. But before we solve this question 2 here, we have to understand the question properly. Now, this is a way to understand physics. To understand physics, you list out the given parameters. After them, you know what you are asked to calculate, and you use the appropriate formula, okay? If there's any condition, you can apply the condition, okay? So let's solve this question here. But before then, let's understand the question. They said a particle is projected horizontally at, okay? Remember, if I have something like this horizontal, please take note. Now that is S, along S. So this particle is projected along S as this, okay? That's horizontally, okay? First, at 10 meter per second. Now this 10 meter per second here is telling us about velocity. That is, the velocity along S axis is said to be 10 meter per second. That means V of S is equal to 10 meter per second, okay? We have gotten the first parameter here. From a height of, the next is height. But do not say distance. If they say distance, distance will be along this area. So they say height. That means height is always on Y axis. Please take note. This is height. Y here is distance. Here should be distance. Please take note. So since it's height here, it means that it's going to be along what? Y axis. So our height is given to us as what? 49 meters. That is the height here. Please take note of this. It said, calculate the horizontal distance covered by the particle before hitting the ground. Okay, that means this question here is focusing on tau. That means when an object is being launched on a tau, please take note, before hitting the ground. It's not in a parabolic curve. Now, if it's in a parabolic curve, how do we know these two shapes here? We have two shapes in solving projectile motion. One, when an object is launched on a cliff or on a tower, okay? The second one is when an object is in a parabolic curve. That means in a parabolic curve, here, I will tell us when an object is launched in a parabolic curve. All you have to do here is to hit the subscribe button to get the next video, okay? Now, but let's solve this question first, please. At this point here, our V of S here is given to us as 10 meter per second. Our height is given to us as what? 45 meter. And we are asked to find the what? They say calculate the horizontal distance. We are asked to calculate the horizontal, that is the D, the distance. Please take note. We are asked to find the horizontal. So any distance here, any horizontal distance is distance here. So we are asked to find the horizontal distance here. So let's write down the formula for projectile motion when an object is launched on a tower or on a cliff before we solve this question here, okay? But these are the given parameters here in terms of relating to this question here, okay? Okay, from the given question here, these are the given parameters. That is the given parameters here is said to be V of S. We have this to be 10 meter per second. The height is given to us as what? 45 meters. While distance is not given to us, okay? But we are asked to find distance, okay? Now, class, since this question is focusing on when an object is launched on a tower or on a cliff. So what are the formulas here? Our two formulas here, we have to know. Is said to be height, that is half gt squared. Please take note. The second one here, class, the second one here is said to be distance, that is Vs times t, sorry. Okay, now let's go. If I want to calculate distance, which is this one here, that means V of S must be given, which is given to us here. The time must be given, which is not given. So it means that I have to calculate the time from equation 1. After then, I can now calculate what, please, class? The distance. Hello, class. Please listen. I can now calculate the time here from equation 1 because in equation 1 here, the height is given to us here, which is 45, and the g is constant, which is what? 10. Since it's not given to us here, we use the approximated value. And we can now make t the what? The subject of formula here. So solving that, we are going to use equation 1 first. That is using h equal to 1 over 2 gt squared. So let's replace. H is given to us as what? 45 is equal to 1 over 2 times 10 times t squared. Our purpose here is to make t the subject of formula, not t squared. But before then, this can cancel this. I'll be left with 5 here. So this is going to be 45 is equal to 5t squared. Please take note of this, okay? Now, making t squared only the subject of formula here, I'm going to have something like this, making t squared the subject first before making t the subject. I'm going to have something like this. Now, let's make t squared the subject before making t the subject, okay? Look up here. So this is going to be, divide both sides by what is attached to t squared. So this is going to be t squared will be equal to 45 over what? 5. So 5 go here will give us 9. 5 go here is 1. Please take note. So our t squared will be equal to 9. So making t the subject of formula only, t only will be equal to having square root of both sides. Please take note. Having square root of both sides, square root here, square root here. When you square root here, this will be t. Square root here, this will be square root of 9. And 9 is a perfect square, okay? Now, square root here, this will give us class 3 seconds. You can point your calculator, okay? So this is my answer in terms of t. But remember, in this question, we are not asked to find t. We are asked to find the distance. So what is the formula for distance when an object is launched on a tower here? Let's use the formula here to find the distance. Okay, let's use the formula here to find the distance when an object is launched on a tower, okay? So the distance here is equal to Vs times t. So let's replace this. Vs here is said to be 10 times the time here is obviously class 3. So point your calculator here. 10 times 3 is obviously class 30 in what? Meters. So this is my answer, please. So class, the next topic here is to treat projectile motion when an object is in a parabolic curve. And we are going to solve some of the advanced questions in terms of projectile motion, okay? Thank you.